is a section where if you're not really the kind of person that pays attention in class, you want to make sure you're paying attention. You've never seen this before. It's brand new to you. And if you're not paying attention, you're going to miss something that's simple. This doesn't have to be difficult. And out of all the things that I've ever had people tell me, when am I going to ever use this? I've actually had people come back to me years later and say, I wish I'd have paid more attention because now they use this all the time in a field that they chose. This is used in, if you're going to survey anything, this is used all the time. It's used in a lot of medical fields to pinpoint where they're going to put radiation when they're treating cancer. They use it when they're looking for X-rays and where they want to focus something. It's used in astronomy. We have no way to get in our car and measure the distance from the Earth to the moon, do we? But we can use trigonometric ratios to find those lengths. So it's used in a lot of different areas that people just wouldn't think of where it's going to be used at. So, first off, let's talk about what trigonometry actually means. It is a branch of math that studies the relationship of lengths and angle size in triangles. It's a branch of math that specializes, that studies specifically the relationship of the size of a side and the size of an angle. A trigonometric ratio specifically is a ratio of the sides of a right triangle. So are we going to use trigonometric ratios on obtuse triangles? No. How about acute triangles? No. Specifically, we're only going to use them if we're dealing with what? Right triangles. Everybody good? So, sine, cosine, tangent are three trigonometric ratios. When you look at your calculator, sine is listed as sin, sin. It's the ratio between the leg opposite an acute angle and the hypotenuse. So if I was looking at this, if I say sine B, this is an acute angle. They said it's a ratio. A ratio is a comparison of two things. The leg opposite the acute angle. What's opposite of angle B? What's opposite of angle B? The little b. And what's the hypotenuse? The little c. So the sine of angle B would be equal to the side that's opposite over the hypotenuse. The cosine of B it's a ratio between the leg that's adjacent to. Well, if it's adjacent to it, it has to be next to it. Well, it looks like A and C are next to it. How can I tell which one's adjacent and which one's not then?
It says the leg adjacent and then the hypotenuse.
Right, and C is going to be always what? The hypotenuse. Okay? Because it's across from that 90-degree angle. So the one that's adjacent to it is going to be A, and the hypotenuse is going to be, and this would have been opposite of it. This is adjacent because it's right next to. The tangent of B. It's the ratio between the leg that's opposite the acute angle. So opposite of it was the little b. And the leg that's adjacent. The leg that's adjacent is the little a. And underneath you see this. Why? Why would that be there? Well, I can tell you, I'll never forget this. We can't do things like what we used to do in classrooms, but my geometry teacher, the day that we did this, he's kind of a short, kind of roly-poly fellow, so that kind of helps your imagery. He came in wearing a long Indian headdress, chanting, Soka Toa, Soka Toa, Soka. Come on, chant with me. Soka Toa, Soka Toa. It seemed like a silly thing to do, but I'll never forget it. And the reason we learn it that way is the S stands for sine. The O and the H is opposite over hypotenuse. Co. C stands for cosine. A and H stands for adjacent over hypotenuse. Toa. T stands for tangent. The O and the A, opposite over adjacent. SOHCAHTOA. It's how you can remember which one is which ratio. Now, trig ratios deal with acute angles of a right triangle, not the right angle itself. So, there would never be anything like sine C, tangent C, cosine C. Why wouldn't these exist? What's opposite of angle C? The hypotenuse. So it kind of falls apart. It has to be one of the acute angles. Now, trig ratios can be represented as a fraction, and usually if they're going to do it as a decimal, they round to 2 decimal places, or we would say round to the hundreds. So let's take a look at this first example, the sine of P. If they're going to use P, what I'm going to do is I'm going to circle where P is at, and I'm going to label all 3 parts. What's opposite, what's adjacent, what's the hypotenuse. And the first one I always identify is the hypotenuse. Because no matter which function I'm using, that hypotenuse won't change its location. No matter which angle I'm using, it won't change its location. What's opposite then of P? The 4. This is opposite, which means the 3 is adjacent. The sine of P, sine, S-O-H. So, right? Opposite over hypotenuse. This would be 4 over 5. If this fraction can be simplified, we should simplify it. This one cannot. So the ratio of the sine of P is 4 over 5. And in decimal form, this would become 0.8. And I might put 0.80 if I want to keep the hundredths place there. Cosine of P. C-A-H. Adjacent over hypotenuse. What's adjacent?
3.
What's the hypotenuse?
5.
And again, I should simplify this if I can. And this is going to be 0.6. I might put 0.6. I might even add the 0 if I want to make sure it's to the hundredths place. Tangent of P. That would be opposite over adjacent. 4 over what? 4 over 3.
So it's 1.25.
It's what?
It's 1.3.
It's 1.33. And we're going to round to the nearest hundredth. Okay. Everybody okay with this first example? All we did was simply state what the ratios are. The ratio itself is nice, but we can actually use the ratios to find a missing side length. If they give you one of the acute angles, this is kind of where you want to start. Look at where that angle is. What other pieces are we looking for or do we have? This is opposite of it. The 5 is the hypotenuse. Which function uses opposite and a hypotenuse? So does, right? So I want to take the sine of the angle, which is 17, is equal to what is opposite, x, over 5. This, believe it or not, is just an algebraic equation. This sine over 17 is just a numeric value. I'm going to leave it this way for a second. I'm not going to put a number there. If I wanted to solve this for x, how would I get x by itself? I'd multiply it by 5. Now, I want to make sure that everybody understands how to use their calculator, because everything else from this point is just a calculator function. Let's take a look at the next example. In order to decide whether I'm using side, cosine, or tangent, I have to know where I'm going to start. They've given me an angle measurement, so I'm going to start by looking at the angle. Which pieces do I have? The opposite and the hypotenuse. Which function uses opposite and hypotenuse?
Cos.
That's so.
Opposite and hypotenuse.
So.
So, sine. What am I taking the sine of? 63. The sine of 63 is going to be equal to the opposite, x, over 14. And what am I going to do to get this x by itself?
Multiply by 14.
Multiply both sides by 14. So go ahead and key that in and see what you get for an answer.
Get 12.47.
12.47. Anybody not getting 12.47? What am I going to look at first? I'm going to look at the acute angle that they've given me. This is the hypotenuse. This x is what? Adjacent. Which function? This is a cosine function. The cosine of what? 50. The cosine of the angle is equal to the adjacent x over 27. And to get x by itself, I'm going to multiply by 27. And you should get 17.36. Questions, anybody? Again, remember you're going to key this into this style calculator backwards of what you see.
So we have to remember all this like the exam.
And you're going to find that once you've done a few of these, it's like anything else. After you've done a few, if you remember this little acronym, they're pretty easy. It's pretty routine. Where am I going to start in example 5? I'm going to start at angle P because they've given me that acute angle. And then I'm going to look to see what they have. Well, this would be the hypotenuse. There isn't anything there. This is opposite. This is the adjacent. Opposite and adjacent is tangent. What am I taking the tangent of? 21. And it will be equal to x over 15. And to get x by itself, I'm going to multiply by 15. And this is what ends up getting keyed into the calculator. And you should end up with 5.76. When I go to example 6, what am I going to look at first? R. This acute angle where they've given me the measurement. I have the adjacent and I have the hypotenuse. Adjacent and hypotenuse is which function? Cosine. So I'm going to take the cosine of 36 and it's equal to 31 over x. This looks a little different, doesn't it? Can I solve for x when it's in the denominator?
Yes,
Hmm?
divide the, or times by anything,
Actually, I'm going to get the x out of what?
4 or 5 fraction.
I'm going to get x out of the denominator. These would cancel. I now have this. X cosines of 36 is equal to 31. If I wanted to get x by itself now, what would I have to do? Divide by the cosine of 36. This key's kind of funny in the calculator. On this one, you're going to put in 31, divide 36 cosine, and then hit equals. 38.32.
31 and 3.
You've got to key the 31 in first, then divide, and then you could have put in 36 cosine, but remember you need to hit equals. And you should end up with 38.32. Questions? I want you to take a quick look at the worksheet that you picked up. Take a quick look at the worksheet that you picked up on your way in. Somewhere I put a key. When you go to do 6 through 11, where they're asking you for the ratio, you need to remember that you already kind of know something about the sides of a 45, 45, 90 degree triangle, and you already know something about the sides of a 30, 60, 90 degree triangle. If I said that this was 1, how big is this side?
Square root of
This side is also what? 1. And this side would be the square root of 2.
Never mind.
Across from the 30, if I said this was 1, across from the 90 is twice as big, but across from the 60 is 1 square root of 3, which is just the square root of 3. You're going to use these two triangles from 6 through 11 to set up those ratios. And your assignment is that worksheet.